Final lesson of Chapter 3, and it's the final bit of return back to Algebra 1. Because we're in our chapter about parallel and perpendicular lines, this is all about taking equations of lines and producing equations that are parallel and perpendicular to the given lines. Once again, just like last time, if you are feeling super productive, you are more than welcome to start your 3.8 Math Excel. Here we go. Two lines are considered parallel if they're non-vertical, if their slopes are equal. So this is kind of like the theorem, essentially, what I'm given. If two non-vertical lines are parallel, then we know that their slopes are equal. And the converse to that is if we're given that their slopes are equal, then the lines are parallel. So that's kind of, again, like the converse. Big idea that I need you to take away is that I'm looking for slopes that are equal in order for two lines to be parallel. Another given fact. Any two vertical lines or horizontal lines are parallel. So here are two vertical lines, they're parallel. Here are two horizontal lines, they are parallel. Let's go on to our first example. In our first example, our job is to figure out if line 1 and line 2 are parallel. In order for us to determine this, we need to look at the slopes for both line 1 and line 2. So let's first look at the slope for line 1. Once again, slope. I'm going to write this over here. Slope is equal to the change in y values divided by the change in x values. Two coordinates contained in line 1, we have -1, 5 and 2, -4. All right, so my first coordinate I'm going to use is -1, 5. So it has a y value of 5 and an x value of -1. And I'm going to subtract the other coordinate. The other coordinate is 2, -4. So -4 is going to go up with the 5 because it's a y value, and 2 is going to go on the bottom. So when I simplify this, we have 5 minus -4, that gets me 9. We have -1 minus 2, that gets me -3. And when I simplify this, I found that line 1 has a slope of -3. Let's look at the slope for line 2. All right, two coordinates contained in line 2. We have -3, 3, and -1, -4. All right, so let's use -3, 3 as my first coordinate. So we have a y value of 3 and an x value of -3. And we're going to subtract the other coordinate. So the other coordinate has a y value of -4 and an x value of -1. Let's simplify. 3 minus -4 becomes +7. -3 minus -1 becomes -3 plus 1, so we get -2. And what I'm doing is I'm going to compare these two slopes. How does -3 compare to -7/2? Are they equivalent? Well, -3 and -7/2 are not equivalent, therefore the lines are not parallel. So this is what I'm going to write. Not equal. Thus, line 1, I'm going to write the parallel, and I'm going to put a cross through it. Therefore, it's not parallel to line 2. This is my little shorthand. All right, and now it appears to be your turn. Please notice that I do expect you to show your work algebraically, aka find the slope with your lines. All right, if you got the question wrong, please make sure you are checking your work in order to figure out whether or not this statement is true or false, okay? Next example. What is an equation for the line parallel to the line y equals -3x minus 5 that contains a point? If I contain a point, it's most efficient for me to use point slope form because I'm given a point to plug in. All right, so the other piece of information other than the point is I need to look at the slope of the given line. Because we are writing an equation that is parallel, we need to notice that the slopes are going to be the same. Therefore, my value for m in the equation that I produce should be equal to the value of m in the other equation. So here we go. We have y. Now we look at the y coordinate in the point given, and it's 8. So we're going to do -8 is equal to, the slope in the given line is -3. All right, now we have x. Now we look at the x-coordinate in the point given, and it's -1. So we write +1. Here is point slope form of this equation. If I wanted to put it into slope-intercept form, all I would need to do is distribute my -3 and add 8 to both sides. So let's do that. We have -3x minus 3 plus 8. That was me doing all my steps at once, distributing the -3 and adding 8. Notice I have two like terms, so this becomes y equals -3x plus 5. This would be a correct answer, as well as this answer right here. Your turn. All right, if you got the question wrong, please make sure you are checking over your work. Again, it's just most efficient to produce a point slope form answer. All right, the other concept that we've been talking about is the concept of perpendicular lines. So two lines are considered perpendicular if when you look at their two slopes, if you multiply them, you get an answer of -1. That is because these slopes are going to be opposite reciprocals of one another. So if I multiply the two slopes, then they are the opposite of reciprocals of one another. They produce -1. So again, just like with parallels, if I just take it backwards and I write the converse, if the slopes of two lines have a product of -1, then the lines are perpendicular. Fun fact, any horizontal line and vertical line are perpendicular. So here's a horizontal, here's a vertical. Automatically, these two lines are perpendicular. All right, let's look at our first example here. Are these lines perpendicular? So what we need to do is we need to find the slopes. All right, so line 1. Line 1 contains the coordinate -4, 2, and 0, -4. All right, let's use -4, 2 as my first coordinate. So we have a y value of 2 and an x value of -4. And we are going to subtract the coordinate for the second one. The second coordinate has a y value of -4 and an x value of 0. When I simplify the slope of line 1, this becomes 2 plus 4 on the top, so that becomes 6, over -4 minus 0, so over -4. This simplifies to a slope of -3 over 2. Now, let's look at the slope for line 2. Line 2 contains the coordinates 4, 3 and -5, 3. Let's use the coordinate 4, 3 as our first coordinate. So we have a y value of 3 and an x value of 4. And we're going to take away the coordinate -5, -3. So we have a y value of -3 and an x value of -5. So we have 3 minus -3. That gives me 3 plus 3, which is 6. 4 minus -5, so that becomes 4 plus 5, which gets me 9. This simplifies to a slope of 2/3. All right, so let's look at these two slopes together. -3 halves and 2/3. Recall the rule. If when you multiply their slopes you get -1, then lines are perpendicular. So if we have -3 over 2 times 2 over 3. When I multiply fractions, I multiply straight across. So this creates -6 over 6, which is -1. Therefore, line 1 is perpendicular to line 2. And I'm going to write this statement. This is a proper statement. I want to make an observation. Notice, -3 over 2 is the opposite reciprocal of 2 over 3. You flip the fraction and you flip the sign. Your turn. If you got the question incorrect, please double check over your work. Now's your time to double check your work and pause if necessary. We're almost done. What is an equation of the line perpendicular to this line containing this point? Once again, because I give you a point that I'm containing, it's most efficient for us to use point slope form. So I'm going to just jot that down real fast. All right, so the piece that I need to look at is the slope of the given line. Because I'm producing a perpendicular, I don't want to use the exact same slope. I'm going to want to use the perpendicular version of this slope, which is going to be the opposite reciprocal. Notice 1/5 is positive. Therefore, my perpendicular slope will be negative. All I otherwise need to do is just flip the fraction. If I flip 1 over 5, it flips to becoming 5 over 1, but we never write that, we just write 5. So the perpendicular slope is going to be -5. Let's write our equation. We have y. Now we need to notice the y coordinate of the point given is -4. So this becomes +4. We've already identified that the slope is -5. Now we have x. Now we need to see the point given is 15, so we take away 15. And here is my equation of a line that is perpendicular to the given line through that point. Your turn. If you got the question incorrect, please check your answer at this time and look to see where you made your mistake. It's important to learn from our mistakes in order to do better in the future. Here's the final example of Chapter 3. The image is a little bit hard to see on my screen, so make sure you're looking at the picture on your notes. So the baseball field below is on a coordinate grid with a home plate at the origin. A batter hits a ground ball along the line shown. The player at 110.70 runs along a path perpendicular to the path of the baseball. What is an equation of the line on which the player runs? All right, so we need to write essentially a perpendicular equation containing the point 110.70. But it might be first helpful for me to identify the slope of the baseball. I'm noticing that I've given some firm coordinates here. One firm coordinate that I'm given is 0, 0. Another firm coordinate that I'm given is a coordinate of 30, 10. Quite frankly, I find it to be most efficient for us to find the slope using those two coordinates of the baseball. So I'm going to do M of the baseball. Looks like a tennis ball. That's okay. All right, let's use 30, 10 as my first coordinate. We have a y value of 10 and an x value of 30. We're going to subtract the other given coordinate, which was the origin, so 0, 0. Notice I chose the origin because I made it a pretty simple problem. This just becomes 10 over 30. Therefore, the slope of the baseball is 1/3. We now need to find the perpendicular slope because we're dealing with the baseball player running a perpendicular path. So, notice 1/3 is positive. Therefore, the baseball player is going to run a negative slope. The only other thing I need to do is flip the fraction. 1/3 is going to flip to 3/1. So therefore, the perpendicular slope is going to be -3. Again, because they give us a coordinate, I'm going to use point slope form. So y minus y1 equals m times x minus x1. All right, here we go. Y. We have a y value of 70, so we take away 70. We already figured out that our slope is going to be -3 because that's perpendicular to the path of the baseball. And then we have x, and we have an x coordinate of 110, so take away 110. And here is our perpendicular equation to the path of the baseball. All right, you have your final, got it, and then we are all done. All right, if you got it wrong, please check your answer at this time. Well, because we just finished Chapter 3 through Edpuzzle this weekend, this means on Monday we have the chance to do an activity. So we'll actually get to make sure we practice and really understand this content in preparation for your test next Thursday. So as I said before, if you're feeling like you're wanting to be super productive this weekend and want to get a head start in your 3.8 Math Excel, please feel free to do so. Enjoy the rest of your weekend.